See, how can we solve this question? In the circuit shown in figure 3, the switch is open and the capacitor is relaxed. Now, in this condition, switch is open. At t equal to 0, the switch is closed for a duration of 40 milliseconds. Means at t equal to 0, the switch is closed. So, at t equal to 0 minus, switch was opened, right? And then at t equal to 0 plus, switch is closed. Okay, for a duration of 40 millisecond, it close for only 40 millisecond, but then it opens. Means from t equal to 0 to 40 millisecond, which is closed, right? This is what they mean, है ना? कि 0 से मिले 40 मिलीसेकंड तक switch is closed, उससे पहले before that switch was open, and after 40 millisecond also which was opened. Correct? Now they said determine or derive the capacitor voltage expression. So as you know, Vc of 0 minus would be equal to Vc of 0 plus. So we'll calculate for Vc of 0 minus, right? Now at Vc of 0 minus, that means the switch is opened. And if the switch is opened, charger will be in the discharging condition. Correct? चार्जर कैसे होगा कैपेसिटर कैसे होगा डिस्चार्जिंग कंडीशन पे सो द डायग्राम वुड बी एट टी इक्वल टू 0 माइनस डायग्राम कैसे होगा resistor and battery not connected, there is a connection of only resistor and capacitor, right? So in this case the equation would be for the discharging condition, and discharging condition V is equal to V naught e raised to power minus t by tau, where V is equal to V naught is 0 because at this condition there is no voltage across the capacitor. So the voltage across capacitor is always for this case 0. Okay. Now in the next case they ask you the capacitor voltage for 100 millisecond for the instance which was closed. Like after